So welcome to this video on how to use the concentration curve R code using RStudio. So RStudio is this software package that you see right here, these four windows. If you don't know much about RStudio, I recommend that you download it and play around with it. And that there's a lot of online help. There's a lot of online videos on how to use it. But basically what I'm going to do is I'm going to be running this script here on the left, top left. And then you're going to see here in the console below some of the results, and then you're going to see some of the other results for the plots, which are going to be maps, and a graph here on the bottom right side. So the code, you set your working directory. You might have to change this according to your own computer, where the files are saved that you downloaded. So here, if you click on files, you see this is all in the repository on GitHub that you should have downloaded and unzipped, and you can see them all here. So what I'm going to do is I'm going to go ahead and just get started here. So this explains part one, what the project is all about. And so I'm going to go ahead and read in the homicide data. So what I do is command enter on my Mac computer. And you can see that it's been read in, and it has been read into, let's go ahead and clear this so you can see how it works. Let's do it one more time. That's the thing about R. You can do it again if something needs to function. Okay, so I needed to load these libraries first. And now let's read in the data. Homicide all is over here, so I'm going to open it so you guys can see. It's got an address, when the event happened, the year, and the community statistical area where it happened. So we are going to subset the homicides only to get 2016 homicides. So in 2016, there were 319 homicides, and you can see those here. So these are the ones that happened in 2016. You can see event date is only 2016, and that answers one of the questions here. How many were there? So we're going to write it as a subset so we can use it later. Okay. And now we are going to bring a shapefile, which is a geographic file. We're going to bring it in so we can get some data off of it. And you can see the shapefile info here. It's got a lot of values, a lot of variables in it. We're going to read the shapefile into R. So now you see that over here it's CSA Baltimore. You click on it and you can see everything that's in that file. And then I'm going to transform the coordinate system because coordinate systems are good to, because you cannot, basically the world is a globe, right? And you cannot map flatness on a globe, and so you need to have a coordinate system. It doesn't matter a lot in small areas because that's pretty flat, but once you get going over the entire state or the world, then yeah, you know, it makes a difference. So we changed that. So now I'm gonna change the shapefile into a data frame. So that CSA Baltimore shapefile is now a data frame, and you can actually see that it has all this information in it on the polygons. So those are the shapes of where the CSAs are. I'm going to summarize the number of homicides by CSA from my homicide 2016 data. So here we have a table summarizing that in this CSA there were this many homicides, and you can sort it up and down so you can see which CSA had the most homicides and which CSA had the least. So you remember there were 55 CSAs in Baltimore, and only 46 of them had one or more homicides. So you can kind of see where these homicides were, and you can create some code for yourself to see where there weren't any homicides. Okay, so I'm going to go ahead and bring in the demographic information that I got from the Baltimore Neighborhood Indicators Alliance as a data from BNIA demo. And you can click on that. You can see in this CSA there was this much poverty, population, and this much poverty. And the population helps me get homicide rates, and the poverty helps me understand the level of poverty. So I'm going to join these two data sets, BNIA demographics and homicide by CSA, so I can assign the number of homicides. And you see CSA info. Now I have the CSA, the population, poverty, and the total number of homicides. So if I have the total number of homicides in the population, I can do a calculation to get homicide rates. But first, I need to get rid of some of the NAs, not applicables, and turn them into 0, because that'll help in the calculation of the homicide rate per 100,000 residents. Because if you divide by, if you get an NA in the numerator, it's going to give you an NA throughout. You actually need a 0 or a number. So here, now the homicide rate has been input in there. That's set to 1. CSA Baltimore. Nope. Where did I put it? Homicide. CSA info. Yes, so CSA info. So now I have the CSAs, the population, poverty, total number of homicides, and the homicide rate per 100,000. And I can actually sort this up. And you see that those CSAs that didn't have any, they're right there, and their homicide was 0. And the one that had the most, homicide rate 134, which is pretty close. It's not the highest because there's a little bit less people in the next CSA over. So we're gonna save this for use later on if you want to use it later on as its own data set. And so keep moving around, moving along. Now we're gonna join the CSA, the counts of homicides, the homicide rate, and all that to its own polygon. And now we get to do a map. So now we're gonna do this map. You're going to see it pop up over here on the lower right. So basically, I'm getting a map of Baltimore. I'm zooming it into Baltimore. It's a black theme map. It's going to have all the CSAs on it, and then the shading is going to be by level of poverty. And you'll see it here in a second. Keep running the code. And now let's look at what we created. There it is. So this is a percent of households under the poverty level by community statistical area in Baltimore. So you can see how you have the darker reds is the higher number of households under the poverty level. So all this code here, actually, beginning here and all the way through here, created this map. And you can go through the code, and you can pretty much see where what queued for what. So pure is the scale here from purple to red. The title, percent of households under poverty for the scale, etc. So you can play with that code and look at it yourself. And then we're gonna save that as an image to use in the report, on the website, etc. And now Baltimore chloropeth of the homicide rate. So same thing. That's a good thing about coding, is that I don't need to remember what I pointed and clicked at. I just copy and paste the code and change my data sources. So same thing, I have the map already uploaded, and now I'm gonna just create this other map using data. You can see the data here. Where is it? Data equals CSA Baltimore 2. CSA Baltimore 2. So using these data here, it has poverty, population, poverty, homicide rate, latitude, longitude, the information of the geometries. There are these geometries here, and using the fill, which is going to be the homicide rate, I created this map. See, pretty simple. So now we have the homicide rate. So I'm going to go ahead and save that as a PNG file. So let's look at these using Patchwork, which is a software that somebody wrote up. This guy named Thomas P. 85. Go look at his stuff. It's pretty good stuff. Let's look at them side by side. And so here we have the map side by side, and you can click on the zoom button there. You can actually really zoom in. It'll rescale it for you. There you go. So what does this tell us? What is the relationship between the homicide rate here on the bottom and poverty here on the top? Do you think that there's some spatial relationship between the two? That is, where there is more homicides, there is more poverty, or vice versa, where there is more poverty, there are more homicides. All right. And so the answer is yes. There's something going on there. Let's save that image for later use. There's something going on there, and so we wanna visualize it. So we're gonna make a scatter plot to look at what's going on. And in the scatter plot, you can see that the lower the percentage of households under poverty, the lower the homicide rate. And your regression line is that dotted blue line right there. So it's a kind of a linear relationship. There's some outliers up here. The low S line tells you that there's some pooling left and right. But basically, yeah, for the most part, the higher the poverty, the higher the number of homicides, homicide rate. And remember to use rates, because that accounts for the population differences in populations. So our final graph here is going to be a concentration curve. And so to do that, we need to rank the CSAs in our data set by poverty. And then we get the cumulative number of homicides. And then we calculate the cumulative percent of homicides. And so this is all changing CSA info ranked. This is all changing this data set. So it ranked it by poverty, 47 on down. And then it ranked it by cumulative percent. And then we're going to generate values if all things were equal. We're going to make a line. So now you see that there's a you'll see that there's a line being created here, equality line. And then get the cumulative sum of the equality percentage. So now we have that done over there. And then we make the concentration curve. There's a little bit of code. And the concentration curve is going to be named CSAs. Alright, so ready for the curve. Let's run this code. We're going to run this code from here to here to create that curve. But remember, once you write the code, you can use it over and over again. You just change your data and change the variables that you're using. And now let's look at the concentration curve that we created. Here it is. So again, having the code, if I change the data and I change the variables, I can look at the distribution of homicides by not poverty, but like other workers. Let's look at it nice and big. And I added some lines here at the 50% and the 90% so you can answer some of the questions that are included in the code. But basically, these CSAs, community statistical areas here at the bottom, had 50% of the homicides. These over here at the top had only 10%. So the wealthiest had 10%. The poorest had 50% of the homicides. If all things were equal, the red line would fall upon this line here in the middle, which is the line of equality, like everything is distributed the same. But it's not. So there's some, the poorest neighborhoods are bearing more of the brunt of the homicides. So here's a good visual representation of that. We're going to save our curve for later use. And then just some questions here for you guys to do. So this whole thing, if you read the steps and you try to read the code and understand what's going on, and if you had a little bit of R, I haven't had a lot of R training myself. I've only been really heavy duty using it for the last 2 or 3 weeks. But I was able to create this over a weekend. So this, now you have the code that I've given you, and you have some of the data. You can change your data and come up with your own concentration curves that are, you can come up with some pretty good conclusions. You can come up with some papers out of this too. So that's there for you guys. If you have any questions, hit me up on Twitter or Facebook.